Kiddos, hope everyone's doing well. In this video, we're going to do a quick review of sine, cosine, tangent, finding sides of right triangles, and then what we're going to do is we're going to talk about quickly how to find angles using the same idea, sine, cosine, tangent. So here's a quick review, right? We start with any right triangle, and it has to be a right triangle, and we declare some reference angle x, or theta, right? And so by that reference angle x, we define the side opposite, the side adjacent, and the hypotenuse. And remember the three ratios we've been working with. Sine of that angle x is equal to the ratio of over h, opposite of a hypotenuse. The cosine of that angle x, that reference angle, is equal to the ratio of a over h. That's the ka part of SohCahToa. And the tangent of that same reference angle x is in fact equal to the ratio of, let's keep the color straight, O over A, right? So here are the three trig ratios, and we kind of remember it with this little SohCahToa idea. So that said, here's a quick review problem, right? So what if I wanted to find the sides, right? So we start off with, and let's get a little crazy, let's look at that triangle. And let's say the hypotenuse is 8, and let's say this angle right here is, I don't know, 41 degrees. Right, and let's say I wanted to find, how about this side right here? Right, we'll call that x. So based on this particular reference angle, 41 degrees, the side x I'm looking for would be my opposite. And I would know the side, which is called 8 hypotenuse, right? So therefore, I'm going to use a sine ratio, and by doing so, I have the sine of that 41 degree angle is equal to the ratio of the side opposite that, which I'm looking for, and 8, which I know, right, over h. Right, it's a little bit easier to solve for algebraically. Multiply both sides by 8. Here's my answer, and then I turn to my calculator. 8 sine 41. Make sure I'm in the right mode, degree, yep. Press enter. There we go. So I get x is that side, 5.248, right? And that makes sense. It should be less than 8, right? So what we're going to establish today is a way to use the same ideas to find not sides, but angles. So let's start with a little clear piece of paper here. And let's suppose I have this little 5, 12, 13 right triangle. Right, that's one of those special right triangles we talked a little bit about. 5 squared plus 12 squared equals 13 squared. So let's say I want to find an angle, x, right? Or both angles, x and y. What I can do is I can use the same sine, cosine, tangent ratios to help me get the angles, right? So here I know the sides, I know it's a right triangle, so I can find the angles. So let's suppose, I want to solve for x first, right? And the cool part is you have lots of options here, but since sine is the easiest, I'm going to use the sine. So I'm going to just temporarily ignore the 12, and I'm going to use 5 and 13, right? So what I want to do is set up one of the three trig ratios that will include that angle x, and write what that sine of x for this particular part is equal to. So I randomly choose sine of that angle x. Now I'm trying to solve for that angle x. Unlike the last problems, last couple days, right, we've known these angles, right? And we take the sine or cosine or tangent of those angles, right? What we're solving for up to now has been a side length, right? Let's find that side length. This is a little different, but we're going to approach it at first in the same way, right? Using the sine of x is equal to the ratio of 5 opposite over 13, right? So I know the sine of x is equal to 5 over 13, right? Sine of that angle is equal to the O over H ratio, opposite over hypotenuse. Now, look what I'm trying to solve for, this x here, right? But the thing is, how do I undo taking the sine of x, right? I want to undo x. I want to end up with x, which is my angle, equals whatever, right? Well, we undo x in the same way we undo any other function, using the inverse, right? So what I'm going to do is now I'm going to take the inverse sine of both sides, okay? Now remember what an inverse does, right? It undoes a particular action, function, right? Like squaring and square rooting, for example. So what I want to do is take the inverse sign of both sides of this equation right here. Now watch what that looks like, right? On our calculator, the inverse sign button is second sign, right? I'm kind of circling it right now. The notation that we use for inverses in general is sine to the -1. So I'm going to take the inverse sign of the left side, and I'm going to take the inverse sign of the right side. Right? Okay? Now, inverses undo one another. So if I compose the inverse sign of the sine, remember that's just a way we write inverse sine, right? Or the arc sine. But to take the inverse sine of both sides, what happens is when you compose the inverse sine of the sine, whoop, whoop, because they're inverses, I just end it with x. How about that? Well, that's what I want, right? Now, how on earth do I figure out what the heck the inverse sine of 5/13 is? Well, that's what I'm going to turn to my calculator. I'm going to press second, to this button right here, sine, and up pops the inverse sine, and now I just press 5/13. Oops, not 5/16, 5/13. There we go. And that is indeed what x is. Now remember what x is, that's my angle, right? So I've successfully solved for this angle here by using the sine function and then undoing it with the inverse sine. Okay? Now if I want to get y, I could certainly add 22.62 plus 90 and then subtract that from 180 to get y, right? Or remember the x and the y have to be complements essentially. They have to add to be 92. Okay? So we're using the same idea to begin with, right? Sine of x, and now x is our angle, is what we're looking for, is equal to the ratio of O/8, right? So we take the inverse side of both sides, we get the angle. Now let's look at the same problem, and let's say we didn't take the sine. Excuse me. Allergies, killing me. So let's take the same triangle, right? We had a 5, 12, 13. And let's try to solve it a different way and see if we get the same answer. I'm curious. I'm really curious. Remember, we're trying to solve for that, right? And we know that's 5 and that's 12. 5 squared plus 12 squared ends up being 13 squared. So I just happen to choose the sine function to begin with. What if we started using the tangent function, right? So what if I wrote the tangent of that angle x, is what I'm solving for, is equal to not 5/13, that's O over h, right? But if I'm using the tangent to solve for x, since I know three sides, I can use sine, cosine, or tangent. The equation, the ratio would be tangent of x equals the ratio of opposite 5 over adjacent 12. So how do you think I'm going to solve for x here? That's right, I'm going to use the inverse tangent. So I'm going to take the inverse tangent, which looks like that, the arc tangent, inverse tangent, of both sides. Right? And because it's the inverse tangent, what happens is the inverse tangent of the tangent of x ends up being just x. They undo each other. They're inverses. That's what they do. Right? So x, the angle I'm looking for, let me give you that view, sorry, ends up being the inverse tangent of 5/12. So, now I'm going to turn to my calculator. Second, just once, tangent, that's the inverse tangent of 5/12. Oh my goodness, the same thing. That's crazy. So why is that happening? Well, I'll tell you, it doesn't matter which one of the three we use. As long as you set up the correct equation to begin with, you will be in good shape. Okay? So, I have two problems for you to consider for tonight. Again, this idea is very similar, right? But now we can find angles too, right? With the same SohCahToa business, right? By undoing our original equations with the inverse, sine, cosine, or tangent. All right? Here are a couple problems for you to try. These are your two homework problems for tonight. You can pause it here. Good luck. May the force be with you. You guys are awesome. Bye-bye.